Welcome back to part 12 of our DIY Autonomous Mobile Robot Building series. If you missed any of parts 1 through 11, check out the links in the description below or access the full playlist at the end of this video. In part 11, we made steady progress on the chassis design using Fusion 360. Today in part 12, among other components, we'll design a rotatable catch for defining the insertion stop position of the 9-volt battery. Let's start with a section analysis to check a few things. Select section analysis from the inspect menu, swivel the design so that we can see the vertical lengthwise plane, and then we select that plane. And then we can see the two screws nicely screwed into base 1 via the battery tab, and the wiring on the rear side of the circuit board safely protected by the board guard and the circuit cover. Press OK to finish the section analysis and unhide each outer wall. Activate outer wall 1, select the outer face and select sketch. Press P to project and project the shape of the board guard protrusion onto the face of the outer wall and also the corresponding protrusion of the 0.5mm thick circuit cover, and also project the lower protrusion in the same manner. Actually, because the board guard and the circuit cover are separate components, I thought it would be best to sketch in a rectangle to encompass both projected shapes of the protrusions of these components while utilizing the projected shapes for snap points. Next, use the offset tool, select the rectangle we just sketched and set an offset of -0.2mm. Create a similar offset for the lower rectangle too. Now we want to extrude those rectangular shapes. Let's first hide the circuit cover and the board guard. Now select the entire area within the rectangular shape and extrude by -3.7mm. Do the same for the lower rectangular shape. Activate the main design, and as you can see, upon turning the design around to the other side, corresponding rectangular holes have been automatically formed on the other outer wall. Now we can unhide the circuit cover, the board guard, and the circuit board itself. Next, we want to screw the circuit board to the board guard and circuit cover, so let's measure the thickness from the front face of the circuit board to the rear face of the circuit cover to determine the length of screw that we'll need, and it reads 5.8mm. So let's find a nylon screw for this job from Insert McMaster Car, although I won't be actually using their products in practice. Check the description below regarding the nylon screws I actually used. Select metric M3, and I think a length of 8mm should be fine. Scroll down to the nylon screw, select the step format and download. Move the screw to the front, color it white, modify the component name for better readability, and make 3 copies of the screw so that we have 4 nylon screws. Use the joint tool and select the underside of the screw head while pressing the control key. Select the center snap point and swivel the design back and select the center snap point of one of the mount holes. There we can see the nylon screw gliding into the mount hole. Insert the remaining 3 nylon screws into the respective mount holes in the circuit board in the same manner. I labeled each joint screw to perf board. Next, we need to find a nylon nut to screw onto the end of each nylon screw. Again, we'll use Insert McMaster Car. Check the description below regarding the nylon nuts I actually used. Select an M3 nylon nut and download the step file. Move the nut to the front. I renamed the nut M3 nylon hex nut. Color the nut white, make 3 extra copies of the nut, and join each nut onto each corresponding screw end. I labeled each joint nut to circuit cover. Next, unhide outer wall 1 and also inner wall 1 and battery pack rear hook 1. At the moment we have an M6 washer through which the bolt of the caster wheel fits and onto which base 2 sits. So let's make a copy of that M6 washer and move it up a bit. From assemble, select joint, select the center snap point on the underside of the washer, then select the center snap point on the top of base 2 at the hole, and the washer glides into place. Label the joint M6 washer to base 2. Now it's time to add an M6 nut. In my case, I already have an M6 nut design in my data panel. You can easily download an M6 nut from, for example, Insert McMaster Car. So I'll insert the M6 nut into the design. Now use joint to assemble the nut onto the caster wheel bolt so that the nut sits onto the M6 washer. Before we carry on, we should label the new joint, M6 nut to M6 washer. Next, we'll adjust the longitudinal position of the 9-volt battery using the move tool and move the battery back by 2.5 millimeters, which seems a good position relative to the M6 nut. Unhide inner wall 1, turn the design around to the other side and hide outer wall 2. Since we adjusted the longitudinal position of the 9-volt battery, the notch in the inner wall no longer aligns with the wires from the 9-volt battery snap connector, so we'll need to make a few adjustments. Hide battery pack rear hook 2. The sketch for the notch in each inner wall is on inner wall 1, so let's rotate back to the left side. I eventually found the sketch that includes the notch in the main sketch folder, which means I mistakenly forgot to activate the inner wall when creating the sketch. So I'll just delete this sketch because it was dedicated to form only the notch. We should also delete the extrusion of the notch from the timeline. Now turn the design around and activate inner wall 2. Select the outer face of the inner wall and create a new sketch. Select capture position. Zoom in a bit and press P to project. Then just select the face of the inner wall and hit OK. So we'll first sketch an initial 18mm line from this projected point, then an initial 7mm vertical line, and change that 7mm line to a construction line. Select circle, sketch a 3mm diameter circle, and we need to convert that circle to a solid circle rather than a construction circle. Draw a solid vertical line parallel to the vertical construction line at an arbitrary position but slightly longer. Select the tangent tool and make that line tangent to the circle. Then make the endpoint of the line coincident with the tangent point using the coincident tool. Then simply mirror that line about the construction line using the mirror tool. Finish sketch and cut the notch by 3.7mm using the extrude tool. So initially it doesn't look as though the notch is in the right position. I'll just activate the main design to have a decent look. So it looks as though the notch needs to move forward a little and also a little longer to accommodate the wires coming from the 9-volt snap connector. Activate inner wall 2, edit the latest sketch, sketch 3, which actually activates inner wall 1 as inner wall 2 is a copy. Change the position of the notch from 18 to 19.5 millimeters and the vertical dimension from 7 millimeters to 10 millimeters. Finish sketch and also hide the sketch. Activate the main design again. There we can see that the wires from the snap connector can extend through the notch unhindered by the inner wall. However, once we unhide each battery pack rear hook, since we have deleted the old sketch of the notch, which each battery pack rear hook relied on for part of their profile, it becomes apparent that we need to redo the front part of their design. So let's edit sketch 1 of the battery pack rear hook, which has become unconstrained. Sketch out the dimension of 19.5 millimeters. Sketch a vertical line from that point to a length of 17 millimeters, and right-click on that angled unconstrained line and delete. Now from Create, select Conic Curve. Select a conic curve from the bottom of the 17 millimeter vertical line to the point where the deleted line commenced, and set the distance of the vertex point to 7.5 millimeters. Finish sketch. And use the extrude tool to cut the unwanted section. There we can see we have used the wrong size dimension for the upper dimension, so let's fix that. Edit sketch 1 of battery pack rear hook and change the 19.5 millimeter dimension to 18 millimeters. Finish sketch. Now we can hide that sketch and we can visually confirm that the battery pack rear hooks no longer interfere with each respective notch. While we're here, we can round the corners by 2 millimeters using the fillet tool, and likewise at each corner at the open end of each notch. Let's do a section analysis at 20.5 millimeters from the longitudinal plane to check whether the battery pack rear hook interferes with the body shell. And when we zoom in, we can see that the battery pack rear hook does interfere a little bit with the lower body shell. Hide the body shell and edit the sketch of battery pack rear hook 1. I won't go into detail, but I'll just modify the lower profile to bring it safely away from the body shell and then finish sketch. So the profile of the battery pack rear hook has been redefined, so we'll use the extrude tool to cut off the excess material along our newly sketched line. Hide the sketch, do another section analysis, and we can see that the battery pack rear hook is clear from the body shell. Now we need to start thinking about joining the two inner walls together, so first hide battery pack rear hook 1 and activate inner wall 1. Select the outer face of the inner wall and create a sketch. Press P to project and select the entire face to project the entire profile. Change the line type to construction. Sketch a 10mm vertical construction line from the rear top corner of the rectangular opening. Then sketch a 20mm diameter circle centered on the endpoint of that construction line and a small inner circle having a diameter of 3mm. Extrude the protruding circular section by 3.7mm and hit OK. Cut the 3mm hole by extruding by 3.7mm. Hide the sketch and activate the main design again. Unhide the body shell and do a section analysis at 16.8mm from the center, and we can see that the circular portion of the inner wall is not even close to the body shell. Actually, we might edit the sketch and adjust the dimension of the circle from 20mm to 12mm and finish sketch again. Hide the sketch and we can see that both inner walls have automatically adjusted to the new size of the circular shape. Unhide battery pack rear hook 1 and activate it 2. Create a new sketch and select the outer face as a sketch plane. Press P to project, select the inner wall including the newly created circular shape and hit OK. Then extrude the circular shape by -3.7mm, unhide the sketch and form the hole by extruding by -3.7mm. Hide the sketch and activate the main design again. Hide inner wall 1, switch to the top view, hide inner wall 2 and hide the 9V battery. Next, edit the sketch of base 2 and use the line tool to sketch a line across the base at the 8mm mark and finish sketch. Use the extrude tool to remove the 8mm section of the base, as I decided that I wouldn't need it anymore. Unhide inner wall 2, the 9V battery, and unhide inner wall 1. Unhide sketch 4 of inner wall 1, then right click to edit this sketch. Select the circle we have just sketched and also the inner 3mm diameter circle. Right click to create a copy of the two concentric circles. You'll need to check Create Copy on the Move Copy palette to make a copy. Then move the copy of the circles to the left and down a bit and then hit OK. Then select the tangent tool and make the outer circle tangent to both the angled front side and the lower side. So the 3mm hole looks a little too close to the rectangular opening, so I tried adjusting the larger circle to 9mm, which moved the 3mm circle away too much, so I finally settled on a diameter of 11mm, and then finished sketch. Select and extrude the 3mm hole by 3.7mm. Let's unhide outer wall 1 and activate it. Select the outer face and create sketch. Press P to project and select the entire profile of the outer wall. Next, we need to initially hide the outer wall to select the 3mm hole on the inner wall, then promptly unhide the outer wall again, and there we can see the 3mm hole projected onto the outer wall. Finish sketch. Select the profile of the little hole and extrude by -3.7mm. Activate the main design, hide outer wall 1 and inner wall 1. Create a new component and label it battery cat. catch. We also need to hide the left servo in order to access the central vertical plane. The plane is still quite hard to see, but it becomes more visible once you select it because it turns blue like this. Then create a new sketch on that plane. Zoom into the area where we form the 3mm hole and press P for project. Project the 3mm hole from the inner wall, the front underside portion of base 2, the front end of base 2, the rear end of the 9-volt battery, the top surface at the front of base 2, and the inclined edge of the inner wall. Hit OK. Select the circle tool and sketch a 3.2mm diameter circle centered at the center of the projected 3mm hole. Then sketch a concentric circle with a diameter of 9.5mm. So this donut shape is the pivotal mount of the battery catch or stopper. And then just build upon this shape around the upper and lower sides of the front end of base 2 and against the rear side of the 9-volt battery in this manner while utilizing the tangent tool. As you can see, I have utilized the conic curve tool to design the lower latch part of the battery catch, and I also used the dimension tool to constrain the vertex point of the conic curve. I sketched a 5mm circle for the stopper portion that comes into contact with the rear end of the 9-volt battery. Use the tangent tool to constrain and properly position the stopper portion. Sketch a random line and use the tangent tool and the coincident tool to complete the design of the battery catch. I'll just redo this line so that it is tangent to the 3.2mm hole instead of the center of the hole. Finish sketch. Select the extrude tool, select the profile portions of the battery catch, select symmetric for direction, and extrude by 3.7mm divided by 2 because we're extruding in both directions. Activate the main design again, and there we have the battery catch component formed. Unhide inner wall 1, outer wall 1, and the left servo. Now we want some M3 washers, so select one of the M3 washers on the browser, which is one of the washers on the battery pack tab. However, on further inspection, I discovered that I had inadvertently extruded part of the whole of the battery pack tab when I created the washer. So I fixed that by editing the extrusion operation in the timeline. So there it is, fixed. Anyway, select one of the M3 washers on the browser, select the Move Copy tool, and create a copy of the M3 washer. Using the joint tool, I attached the washer onto the outer wall around the newly formed hole. I labeled the joint M3 washer to outer wall. Check the description below regarding the M3 washers I actually used in the implementation stage. To continue, click here for part 13. If the link isn't showing, part 13 isn't quite ready but should be soon. Check the description for my upload schedule. Thank you for watching.